What's up, YouTube? All right. Hope we didn't catch that. Okay. We're muted. Mic's working probably.
Can I subscribe to that?
Like, comment, subscribe. Okay. Okay, I can't actually start here. I have to motivate this. Hello, students. My name is Calvin. I am, as discussed, a full-time content creator with a side gig as a CS professor, right? There are not enough seats in this class. You know, everyone told me if you teach classes with no useful skills that are intentionally difficult for no reason, 30 students won't sign up for it. And you're all in here, right? So my haters are wrong, right? And I'm my own biggest hater. So in a way, I've defeated myself, my arch enemy. I'm going to stop talking. Okay, so my name is Calvin, and my favorite river valley is the Willamette. So I typed that into my least favorite search engine, Google. It's also my favorite search engine because there's only one search engine, right? Someone falsely claimed in here that DuckDuckGo exists. That's not true. You're hallucinating that. Anyways, the current Willamette webpage is like hyper search engine optimized, so I've been unable to defeat it, but I got second place. And if you want to go to me directly, if you type in courses, then I come up, so there you go. I don't know why I got really into search engine optimization for like 2 weeks, but I did. This class is CS 271, which has like 8 names. I don't even know what the official name is. They asked me and then they changed it. And so I called it Systems in Rust. And so that's how you find the Systems in Rust page. I'm going to refer to it as Systems in Rust in the absence of a name that makes more sense. There's 2 things to point out about this. This is not a systems thinking, systems theory, systems engineering, system modeling, or anything like that class. The system I'm referring to is specifically computer systems, and so this is actually a systems programming class. And by systems programming, I mean programming in a language that you can write an operating system in. So that's what I mean when I say systems programming. Why am I teaching you a language you can write an operating system in? Because that's the class next semester, okay? And separately, I would argue that if you really want to learn to think, you should probably learn one of these languages, even if you don't use it every day. Right, so when I'm writing Python, I know what C, not Rust, it's turning into. These classes are not necessarily the component of every liberal arts college undergraduate computer science degree. They are a required component of every engineering college computer science degree. So this class is an elective for the undergraduate Bachelor of Arts, a requirement for the undergraduate Bachelors of Science. You all have been here more than 1 year, so you have the old Bachelors of Science where it doesn't matter what you do. So if you're here for fun, which is, again, kind of weird. So anyways, I'm going to call this class Systems in Rust because I have to call it something. The competing title for this class is Computer Architecture. Most programs that have this kind of class have either a systems programming class or a computer architecture class. I'm actually way more into computer architecture, but I couldn't fit it in the curriculum. I wasn't smart enough to figure out how to teach that class here. So there's actually going to be precious little discussion of computer architecture this term, but the introduction of a systems programming language in a way itself teaches computer architecture, and the real thing it teaches you is about managing memory, which is kind of a big deal. I don't know why I put a paperclip in my hand, so I'm going to try and set this down, and we'll see if I have the impulse control to do that. Okay. That's that. Let's pop some slides up, because do you all love slideshows? Slide decks? Are we all PowerPoint pilled? Me too. Okay. Wonder what I thought I was going to teach today. Okay. So last term, spring 25, I tried this wild, silly, goofy, whimsical thing where I taught a cryptography course that was also the Intro Systems course, and it was awesome. I thought it was so cool the entire time. I don't know if any students liked it, and I don't want to know, and I don't care. But I had a great time, and I'm going to do that again in a different language that I don't know. So the original plan was that I was going to learn Rust this summer. That didn't happen. But I'm guessing I know more Rust than most of you, and I think I can learn it faster. So I'm going to try and stay about 2 weeks ahead of you all, and we're going to see what happens. This is not a race. You do not have to try and catch up with me. That causes me to be stressed out. But, some of you like stressing me out, so maybe that would be a good use of your time. I would sure be completely owned if you all went off and learned a bunch of programming languages for fun on your own time while enrolled in my class. I would be so owned if that happened, right? So please don't do that. I showed you how to get to the course webpage. Should we have a Discord this term?
Yes.
Okay, I'll set one up. I think I have to set it up, right? I can't tell one of you to set it up because you don't have each other's emails. Okay, I'll set up a Discord, but really we should just use the Computer Science Students Association Discord and just spam general, right? Yeah? Should we take a vote on that? I love democracy. Don't not raise your hand if you prefer using the CS Students Discord.
What?
Don't not raise your hand if you prefer using the CS Students Discord. It's a double negation. It's very straightforward. Okay, there is one hand up. Okay, that's two hands, but that's like a halfway up hand. Okay. Don't put your hand down if you prefer having a class-specific Discord. Okay, so no one vote. Okay, we got a class-specific Discord, fine. Much like my favorite democracy, which I'm not going to say what that is, we had very low voter turnout among the 19 to 22 demographic. So we'll think about that. Is that a question, or are you voting?
Yeah. Oh, there could just be like a channel for class-specific questions in the Discord.
There could, yeah. But then what if people in other classes see that and judge us?
We could have our own
I know it's
emotes.
their problem.
It would definitely be their problem. I'm going to make a class-specific Discord, and I'm going to try and trick you all into not using it. Okay. Should I just make one now? No, I don't want to open my email while I'm screen capturing. There's probably like tax documents in there. I tried to change my benefit elections the other day. This is unrelated to anything. My partner got a job, and so now I don't have to pay for both of our health insurance anymore, which is like great for me. Pro tip, save money by getting married. Anyways, I don't really want you all to know what my social security number is. Even though it'd be really funny, right? Okay. Yes, at 1,000 subscribers, I will do a live stream reveal of my social security number. Yeah, so like, comment, subscribe. The YouTube account I use for lectures is like, Google really hates it because I like live streamed another teacher's live stream once for an event, and I guess you're really not supposed to like re-live stream other people's content without reacting to it, so I'm in mega trouble. So it's like impossible to find this account, which is why I direct link to it. But it's really, really hurt my ability to go viral. Okay, so let's do some logistics. Who loves logistics? You all do, right? So I've created a regular expression for how to refer to me, which is that my recommendation is you refer to me as either Professor Calvin or Calvin, but you don't have to do that. I prefer not to be referred to by slurs or obscenities, and otherwise it's pretty fine. One time I did have a student who's now graduated, so I can now disclose this, who for a final project did a like lexicographic sorting of slurs and obscenities. Don't do that, okay? I am always shocked by what you have to say, right? Okay. I have one real degree and 3 fake ones. So I have an undergraduate degree in mathematics, and then there's this like Mickey Mouse subject called computer science that people think is real. If it has science in the name, it's not science, right? We can all agree that, right? So anyways, I also have a couple computer science degrees. Those don't really count. I use they, them pronouns, which I keep forgetting. So like, if you've been trans for like 10 years, you just like assume everyone knows. And I meet 100 new people a year who have no idea how unhinged I am, right? So this is actually very difficult for me to keep track of. Anyway, so a good way to refer to me is, that's Professor Calvin. They're kind of strange, right? I almost said undergraduate. My 7th grade English teacher used me as the example in class to teach my classmates what the word eccentric meant. It was, this is Calvin, they're eccentric, right? That was great. I don't still think about that every day. Right, so college, right? You all heard of college? University, perhaps? So, blah, 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 the American Research University, it's based on a German model, which is based on a French model, which is good for economic development. And the way it's supposed to work is there's supposed to be a fusion of research and teaching. We have a primarily undergraduate institution here, so we have a higher teaching distribution, but this is actually truer to the historical form. The undergraduate degree contains almost as much content as doctorates did in like the 1500s or whatever, right? So anyways, the way your education is supposed to work is I'm supposed to be doing research for fun and not pay and get super jazzed about it, and then start making lecture materials for fun, and then I'm supposed to teach those classes. And so the things I teach are supposed to naturally flow from my research interest, and I would argue they probably do. So I'm just going to tell you what my research interest is. This class isn't really about my research interest, but it is inspired in a way, right? And so my claim is that just as there are bugs in code that makes software, modern hardware is also written in code and therefore may contain bugs. I find those bugs. I would add to this now that I find those bugs using data science techniques, because I'm supposed to pretend I'm a data scientist roughly 40% of the time, right? And so that's a good distribution. Modern hardware written code, that is computer architecture. So that's sort of the basis of the computer architecture side of the systems programming class. Okay, here's the course format. There were a lot of contentious design decisions I made when I trialed this class last year, and so I've tried to do the least popular thing possible. We're going to do lectures on Monday. That's where I'm going to talk at you for 90 minutes. I love doing that because I love talking. Who loves talking in here? Any talkers? Any yappers? All right, that's what we like to see. Okay. There's going to be a lab on Wednesday. That's because after I talk nonstop on Monday, it will take my voice 4 days to recover, so it won't be ready by the next class. My voice hurts right now, and I have 7.5 hours of teaching left today or something. That's not true. That might be true. 6. Okay. Homework is due Friday when this class would end. I'm not going to be here. I read on the internet, and they can't put it on the internet that if it's not true, that you shouldn't make homework due at like midnight or 5 a.m. because students will stay up for it. So I just slammed the homework due date exactly when this class would end on Friday, right? This hopefully bamboozles you into doing things. There's going to be an in-class midterm the week of 10/6. And I think that's because I'm out of town. Is that right? Anyways, you'll be expected to write code in class and not talk to each other, but you can do whatever else you want. The final project is going to be a code submission that is due whenever the final is scheduled. The registrar actually, I think, has now announced final dates, but I got really sleepy while I was reading the table that said when the final exams were, and I got too sleepy to put it in the slides, so I don't know when the final for this class is, though the information is discoverable on Al Gore's internet. It's out there, much like the Aliens and X-Files, okay? Do you have any X-Files appreciators in here? Any Al Gore appreciators in here? Okay, I'm working on my content. It would be really helpful if you could all like focus group something together and converge on some like 3 or 4 subjects you all like that I'm already familiar with. So just let me know when you've done that. Your voices have been heard. Right. Oh, okay, we have to talk about grading policy. This is a rendering error in my Quarto Markdown. This is supposed to be 2 quotes. Your voices have been heard. Quote, I think failing my systems class was the best thing that happened to me. So an absolute psycho said that. And then there's another one. This course demanded strong self-motivation, thus I didn't learn as much as I might have if grading mattered more. Okay, so I'm going to offer 2 grading proposals, and then you're going to tell me what you want to do anonymously. My 2 preferred technologies for grading are ungrading and specification grading. You're going to vote as a class anonymously, and I'm going to update the syllabus before add drop-ins. To introduce these, ungrading is option 1. I am 1 indexing. Sue me, right? Okay. Don't sue me. Don't do that. Don't listen to me. Okay. So here's the tech on this. For ungrading, I'll provide an autograder for all assignments except the final. In some cases, there were a few assignments last term that, like, it did not seem reasonable to provide an autograder for them. They were a little too squirrely. So for those, I just released a reference solution, and I spoiler marked it. And they're still visible. You can go find them from last term, but they're in a different language. It's a reference solution with a rubric. And then I will have a final reference solution that will be secret. I will not show it to you. And the reason for that is the final project you make in this class, you are supposed to be able to articulate to a potential employer interviewing you that it was a personal project you did on your own. So it is like quasi-formulated as a pseudo extension, even though it's strongly encouraged, right? And I think that's because I don't know how I'm getting you internships at specifically tech companies. I think I can get you internships at places that use technology but are not tech companies without this. But I would like you to have a personal project in a systems programming language somehow in the next 6 months before you go up for interviews. The final project is intended to do that. Okay. You do whatever you want. So people are always confused by this. I don't care what you do. I'm going to teach the class no matter what. If I were you, I would come to this class every day. I think it's a very valuable class. If you don't show up, that seems like a you problem to me, right? And then I give you an A because I think grades are stupid. Okay, that's option one. Okay. It is worth noting that under that formulation, it is impossible to earn an A because the A happens whether you earn it or not, right? So some people don't like that. They're like, oh, I want to earn an A in this class. Too bad, right? Option two is specification grading. Specification grading was all the rage probably 2 or 3 years ago. I think it was really kicking off before the old COVID thing that I think everyone lost steam and decided all the students were cheating and lazy and using ChatGPT and all that stuff and got like up in their feels about it. Anyways, it was all the rage for a while. I was never a fan, but it is definitely my second favorite grading technique after true, like full-blown ungrading, right? So the way this works is there's going to be assignments in this class, and you're going to do some distribution of the assignments. They're all graded completely pass-fail, totally binary. You either get points or you don't. And if you hit some number of completion, you get different grades. So here are the example distributions. So basically, there's 2 ways to get an A. You either crush the final, or you get a 90% average over everything except the final and submit something for the final. That's an A. A minus is basically the same thing, but you can do poorly on the midterm, arbitrarily poorly if you turn something in. Or you crush the midterm and you turn in something non-trivial for the final. So in all of these cases, I'm modeling something that I appreciated in some of the harder classes I took in undergrad, where there are in fact homeworks and labs, and those are for you. And if you just happen to show up and 100% the final, no one cares what you did until then, right? This is really good because usually around week 10 of the semester, I get a flood of emails saying, what's the highest grade I can get in this class? It is 100% because you can always crush the final. No one can stop you from turning in a perfect final in this class, except you, right? Here's some further distributions. 90% average on everything, no final, and you show up for the midterm. 80% average gives you a B instead of a B+. And if you don't show up for either of the exams, but you turn in 80% of the homeworks and labs, then you get a B-. You get a C for 80%, a D for 60%, and an F for everything else. So these may earn degrees, right? How does that work? Lab grading is you do the lab is 100%. 90% is you show up for the lab and turn something in. And F is you don't do that. This is my late work policy. You get a 0. I don't care. I'm offering you ungrading as well, so I can have an arbitrarily strict late homework policy. Homework grading is the same. 100% if it passes the grader on time. 90% if it doesn't error and is turned in on time. F if you do anything else. The final is as follows. Create, document, and publish a self-hosting version control system. If you don't know what a version control system, it's Git, so you're making a Git competitor. The entire code base must be in Rust. You're not allowed to use C++. Some of you will try and use C++ libraries, probably by accident. That's fine. Minimum specs is it has to support nested directories, text files, but not binaries. You have to be able to revert changes, and you can use a partner, but not a trio. The late work policy is no. The AI policy is yes, but it won't help. The collaboration policy is no on the midterm, yes on everything else. You have to have enthusiastic consent. Does someone want to tell me what enthusiastic consent is? Yes, so it's the presence of a yes, not the absence of a no, okay? This is what you should be using for everything in your life, but I don't know, I'm not a consent educator. Probably should be. If there's not a forms link here, I should add one quickly. Okay, it looks like I did add one. There's a QR code. Step 1, you should never point your phone at a QR code. Have you lost your minds?
I have a virus now.
Yep. Anyways, that one does work. I vouch for it. And then there's a link if you don't trust me, which you shouldn't. I'm going to look at my watch, and then I'm going to leave the room for 5 minutes, and then we're going to progress.
Did it just swipe my email?
And I'm not just leaving because my throat hurts and I need a drink. I'm doing it to protect your identity. Please don't stage it too long. Exactly.
I'm still working on finding this money.
You don't have to write anything and everyone gets an A.
Yeah.
And specification is the other one.
What's the pressure to run a job? At least I'm grading these now for 5 minutes, we go I might want to do like yeah, by Trump, yeah.
It seems pretty easy. Yeah. I had a reputation for being
Oh, okay.
that really did better.
I have a staff. I have executives that I work with. I have to
Voted.
this is my assistant.
Why are you raising your hand? No, it's anonymous from each other. It's not anonymous to me. Yeah. I have to make sure that students that already know all the content in this course don't vote for one policy and everyone else votes for another one.
What happens if I have like 3 emails on?
Yeah, you can vote more than once. I definitely won't find that out.
But I could skew the data.
Yeah, you can try to skew the data.
If I say Calvin's off,
I'm going to go over it at home and decide what I'm going to tell you.
I don't want to know now.
Okay. My graphics driver. Okay. What's my password?
I think it's your social
It
security
is.
number.
Yeah, I know.
Pretty cringe. Okay. Why do you know my password? There's 26 responses. I would have thought there was more of you in here. Oh, nice. Yeah, ungrading is turbo popular. Yeah, this looks like a fine distribution. I don't think anyone's doing anything that sketchy. Okay. Okay, so students, dear students, you got to vote on the grading policy, which means if I see complaints about it on my course evals, I reserve the right to be disappointed in you, okay? Not in myself. I've done nothing wrong. I am innocent. Yes, I've never done anything wrong yet, but I'm going to tomorrow, right? Okay, on systems. Okay, so I think there's 2 hard things in computer science. I don't know. Probably in computer science research. There's one other hard thing in computer science, just complexity, which we're not going to hit that hard this term. So I think there's two things I need to teach you this term, and I really don't think there's anything else. To draw a parallel to a class you may be familiar with. In CS 151, you really only have to learn to write nested for loops. That's the only thing. Like, once you can write a nested for loop, the class is over. There's nothing we can do that's challenging, right? In this class, once you understand pointers and recursion, it's over. There's nothing I can do that's hard for you, right? But you might be thinking, oh, but I do understand pointers and recursion, and this project is hard. No, that means you don't understand them yet, right? That's just like, I'm arguing that by definition. You're welcome to disagree with that assessment. Anyways, here's an example of recursion. I'm sure this is how we all write Python, right? So that's a lambda with a ternary operator in it, right? So that's, do you all understand what you're looking at there? That's an inline exponentiation through repeated multiplication, right? So that's not confusing to you? Okay, good. It got really quiet. How do you write Python? You don't use the def keyword, do you, and define functions? That's good. Okay, I was worried some of you might do that. So we'll fix that this term. Oh, the def keyword, disgusting. Okay, so Python, as we all know, great language if you don't like coding. So they're hard to understand some abstractions. I don't really know how Linux works, but I'm using it so Indy's nice to me. So I can say x equals 1. I can write a function. Or no, we'll increase. Oh, embiggen, that's what I always call it. Okay, embiggen equals lambda of nothing, x plus equals 1, and that's like extremely banned, right? I don't know how to do this. I'm going to use def because I'm not very clever. Okay, so we're going to embiggenify. We're going to take no arguments. There's absolutely no way I'm going to be able to type that. Okay. Okay. So, and we're going to say x plus equals 1. Okay? And that should work, right? Because I can say x plus equals 1 out here, right? And so then I save the idea of x plus equals 1 as emv. And oh, it doesn't work. Oh, it's crazy. Why doesn't it work? Oh, it's so silly, right? Oh, it's like a goose, because geese are silly. Wow, I almost just tried to pluralize goose as goose, right? Okay. But you're like, well, of course that's like, you can't reference things like that. Actually, I can do whatever I want. I'm an adult, so I can just slam a 0 inside a list here. I can redefine embiggenify to say x is 0 equals x is 0. Wait, can I just do, is that allowed? Does anyone know? Oh, that's crazy. You can probably do this a bunch of times. Like you can do emv for range 10. Oh, that's not allowed? Right. Is that how you all write Python? Here, we'll do it again. I don't like all the nuns. Okay, so we're just going to throw out the result there. Okay, cool. And then probably if we look at x's, oh, well, there's a 22 in there. Because it's feeling like it's 22, everything will be all right. Because I'm dancing like I'm 22, right? Yeah. Any Swifties? Do we like Sabrina Carpenter?
Yeah.
Okay, Sabrina Carpenter. Oh, okay. I saw one sort of like shy head shake negative. I can't decide, right? Because I love Espresso, and I think I love it more than the song. Okay, so I think we can all understand that it is unbelievably cringe that sometimes you have an unbound local error, and sometimes you don't, based on whether you're referring to an integer or a Python data type like a list, right? So that's bad and wrong and evil, and we're going to fix that using Rust, okay? Right? Yeah? Vague agreement? Yes. Okay, I heard some heads rattling. That's good. Okay, so we're going to define both of these things. So a pointer is a variable that does not store a value, but it stores the location of a value. Now, the locations are themselves values, so that's kind of goofy. But the difference between x equals 1 is that is a variable that is named x that has the value 1, and x's, which is equal to a list that contains 1, is that list is the location of the value 1. So I can look up the location and I can change the value there. So this is a way to persist changes across function calls. And this introduces sort of an arbitrary high degree of complexity into programming, right? And then recursion is easy, functions calling themselves to solve subproblems. I took a year of programming before I wrote a loop, because the people that taught me to program only taught me recursion. And you don't actually need to write a loop ever if you can write code recursively. I don't think that was like healthy, but I'm fine now, so I turned out all right. Okay. These things are important because all code that is fast uses these two techniques. It is important for code to be fast because otherwise it's not useful. For a computer to be useful, it's something that has to be faster than a human, and I'm sure we can all add 10-digit numbers together in our heads just as fast as a computer can, right? We just can't do it recursively. So that's the difference between us and computers. So like, what is 10 factorial, right? We can probably not solve that faster than a computer. Can we? I don't know. What's 10 factorial? Okay, so we take x equals 10, and we probably do like, what do you do? I don't know how to do this.
Math.factorial.
Oh no! Oh, okay. All right. Let's move on. Okay. I was having a good time. So everyone asks, why not Python, JavaScript, Java, C#, or C++? C++ probably was viable for this class. I might teach this class next year in CUDA C++, which is C++ on graphics processing units. But I have learned 0 weeks of CUDA C++, and I have learned non-0 weeks of Rust. So we're in Rust this year. Last semester I taught it in C, which I have 14 years of. Why couldn't I do that again? Students, why did you ask for Rust? I think most of you in this room are innocent, but I was getting bullied last semester. Bullying is wrong. Okay. These languages abstract memory. What does that mean? That means that when I wrote x's and x in Python, there was nothing visible in the language that was differentiating them, even though one stored the location of information and one stored the information directly. In C, this is made obvious. In Rust, this is made unimportant, right? So we're switching to languages that keep track of whether you're dealing with references or values, right? Now, I think it's important for you to know this so you understand when your computer is using memory and when it's not. Here's an anecdote. You don't have to believe it. I'm not sure I believe it, but someone did tell me this. My office mate, while I was working on my master's degree, now works at Amazon. And we're not jealous of this office mate's salary, right? This office mate bought a house in Portland and is my age. And I'm like, we're very happy for them. Okay, right? So my office mate writes code at Amazon all day, and every once in a while there's a little phone on my office mate's desk because you have to go into the office at Amazon because workers are less efficient when they don't work from home, but managers are happier when they're less efficient and miserable, right? Okay? And so the phone rings, my office mate, his name's Lee, by the way, picks up the phone, and it's a software engineer saying, why does your code have unpredictable memory performance? Which is not something you ever want to hear if you're like me and my office mate and you do formal methods and write proofs your whole life and you don't really know how programs work, right? So anyways, my office mate stopped writing Lean, which is the formal methods language that all the cool kids are using in mathematics these days, and started writing Rust to have highly predictable memory performance, right? So I'm teaching you that so that you can work at Amazon, just like Indy, who you can go see in the Quad Center and ask if this story is true. Indy will have no idea, but go bother Indy, right? Okay. So, the reason to use Rust. You learn something you wouldn't learn if you only learned one of the high-level languages about programming. You learn how computers work in a way you wouldn't have otherwise. And you can write highly performant code. I claim that those other languages are good languages except for Java. I don't think that's true. I think Python, JavaScript, Java, C#, and C++ are all pretty bad languages. I don't actually feel that way about Rust. So I'm also teaching you a language that I think is not awful. As an educator, we always have to decide whether we teach you the language that we think is most likely to get you a job tomorrow, or the language that we think is most likely for you to learn computer science in a way that you sort of are good at getting jobs forever, right? Or at least we had to make that decision until this year, when now Rust is both languages. That's kind of a big deal. That's why I tried to learn Rust, because someday I might need to get a job, right? I'm worried my content creation gig will dry up. I haven't gotten a new subscriber in months, right? Okay. On Rust. Rust does not directly have pointers in it. This is good, because pointers are impossible to understand. Did anyone take the C version of this class last term? Did you understand pointers at the end of that class?
No.
Exactly, right? And so the first step, okay, here, I'll tell you a funny story. So there's a famous quantum physics class on MIT OpenCourseware, so it's how all of us learn quantum physics unless we actually took the class, right? And the professor walks on screen, so I would be standing up there usually. I have to be over here controlling my computer. And there's a camera, because MIT has enough money to buy cameras, right? And says, well, today I'm at a bit of a disadvantage, because it's the first day of the class in the quantum physics class. And today I don't understand quantum physics, but none of you don't understand quantum physics yet. But in 2 weeks it might be possible that none of us understand quantum physics. That's how teaching pointers works, right? I could stand here and I could say, students, today I'm at a bit of a disadvantage, because right now I don't understand how pointers work. But my hope is that in 2 weeks, none of you will understand how pointers work, and then I will not be at a disadvantage anymore. That's how pointers work. Anyways, the people that designed Rust looked at this, and they're like, what if instead of not understanding things, we did understand things? And they invented Rust, and it seems pretty good. So, Rust has this thing in it called the borrow checker. I'm not that impressed by it. It seems pretty straightforward to me. You can let me know what you think over the course of the term. I don't know how novel it'll seem to you. I'm actually very excited to have a distribution of different programmers in here and to see what your reactions are to Rust. So I'm getting compensation in that form for teaching this class, and I'm excited to see that. But the basic idea is that when you store information in a computer, it should cost you something. It should cost you time, energy, money, efficiency, something of this nature, right? Those bits have to go somewhere. The same way if I ask you to remember 1,000 phone numbers, that will cause some level of cognitive strain. You'll forget to go to the grocery store next week, right? So memory matters. But the way we use memory is a historical accident. It just so happened when people started storing information in computers, they did so using addresses. That didn't have to happen. There could have been other arrangements, right? Rust came along and sort of is storing things by variable name. This seems pretty reasonable. That should be what you're used to from Python. But sometimes the variable names cost money to work with, and sometimes they don't. And money in this sense is additional lines of code. That's what's costing you money, right? So you're going to have to be more careful when you use information. My impression is you should use Rust in every application where either code has to be correct or it has to be high performance. And you should probably continue to use Python if you're just trying to figure out some calculation quickly, right? So, Rust is built on top of what I think is the most important ongoing project in computer science in the United States. There might be things outside the United States that are more important. It is the LLVM. Stands for nothing. It stands for LLVM. It may be used to stand for something, and I'll give you a hint. It's low-level virtual machine. It's not a low-level virtual machine, and they didn't want to change the name, so now it doesn't stand for anything. This is based out of UIUC. Have any of you heard of UIUC? So it's this just unbelievably good university in the middle of Illinois, which no one's ever heard of, right? Have any of you heard of Illinois? That's right. Keep all those hands down, right? Randomly in the United States, there's between 5 and 10 just unbelievably good public universities that are the only reason the United States has an economy and are currently all getting defunded. Anyways, UIUC has the LLVM, which is the only thing that I think is ahead of universities in other countries, right? So Carnegie Mellon has a very good computer vision group that does not seem better than 2 of the top research universities in China. Berkeley has a very good computer vision group that does not seem better. No one's close to LLVM. And what LLVM does is it takes code that humans write, and it turns it into code that a computer understands better than anything else does. So this is a good contribution because we have a lot of code that humans wrote, and we have a lot of computers. And those things weren't really getting along that well for a few years. And now all of a sudden they are. No one actually knows why LLVM's approach works so well. They use this thing called an intermediate representation, which I don't know, right? No one cares. It just happened to work, right? And once this LLVM intermediate representation existed, it became possible to create high-performance programming languages that didn't work the same way computers work, but perhaps worked the way humans' brains worked, right? Because there was this way to translate between them. So Rust works the way a mathematician who spent a lot of years designing elevators thinks that code should work, which is much, much closer to us than a rock that I trapped lightning inside of and taught to think, which is how we used to have to write code. Okay? So that's the contribution of the LLVM IR. What this means, among other things, is that when I was taught recursion for years, I was writing very low performance code because it costs a rock that has lightning trapped inside of it and learn how to think a lot of lightning to think recursively. It costs the LLVM IR no lightning to think recursively because it simply translates those into for loops. And the for loops in the recursion are implemented the exact same way in the actual physical silicon that is processing your device. So what this means is that when we write Rust, we don't have to write code either iteratively or recursively to get better performance. UIUC will cast a magic spell on our code and it will turn into the same machine-readable code no matter how we write it. This is very cool. This is an exciting contribution, and it enables us to write code in novel ways without getting performance cost. You all know what Git is, but I'm going to tell you what Git is again because I don't want to hear I don't know what Git is, okay? If you don't know Git, you should soon. It corresponds to a command. This is a terminal command. This is a terminal-based class. Are any of you scared of the command line? Okay. Goodness sakes. I took a lot of psychic damage right there. Being afraid of the command line is banned, so do some exposure therapy. I highly recommend doing exposure therapy by coming to class on Wednesday. And we're going to learn to love the command line because it's better than other things. And once you use the command line, you can feel good about yourself for no particular reason, right? It's sort of like after you eat an entire ice cream sandwich in one bite, you're just like, I don't know why I did that, but I feel kind of cool now, right? Like that's the command line. And then when you try and do something that could be done trivially without the command line and it hurts, that's the brain freeze you get after the ice cream sandwich, right? Okay. There are, I guess, people that use things other than the command line, and I don't know why. But GitHub is the first and the greatest of the collaboration tools, and it claims if you want a lot of control and flexibility, you can use the command line. That was a lie. I've been using GitHub Classroom for years, and if you want to delete a bunch of student repositories that aren't used anymore, you can't actually do it through the command line interface. You have to write a binary script and submit it through an API call is the only way to automate that. So I don't know why they lied to me, but they did. Okay. We're going to just motivate this with a quick example of Git. Okay, so we have these things called repositories. Many of you have probably previously used Git in the context of GitHub Classroom. Is that basically correct? How many of you know what a repository is? Okay, that's cool. I'm going to tell you what I think a repository is, and we'll see if we agree. So Git is based on sort of having a network of repositories, and the two most natural places to have a repository are on your laptop you bring to class and on github.com. Some of you may have like a Bitcoin mining rig that you leave in your, are they called apartments? Dorms. Dorm rooms? Yes? Is that where we live? Okay. So you probably have a Bitcoin mining rig that you leave in your dorm room so you can use the university's electricity to lose money on crypto, right? And so maybe that's the third place. And so we'll have those three things. And so in class today, I'm going to probably write some code, and I'm probably going to save it locally on my computer in my local repository. So I'm going to call that my fire code, right? Do people still use emojis? Are those? They're not in anymore, right?
It's like the colon with the parentheses in it.
Yeah, I like that one. Anyways, when I write code, the first thing I always do is write an infinite loop. Who loves infinite loops? Let's write one quickly. That was fun, right? Okay. So I take that out, right? And I get rid of that code. So I update it, and then I save my fire code again. Okay? What do we think these slides look like? What is happening here? It worked fine on my PC. Never prepare your slides on Windows and then show them in class on Linux. Or do. I'm not going to tell you what to do. Okay. So we have my code, and then it turns into my code. Then you come into class and realize your code is on your gaming rig that you use for Bitcoin mining in your apartment. Who has a Bitcoin in here? It's too late. We know. Now we know. All right. Okay. Everyone remember who has a Bitcoin. Okay. So I can save my code on GitHub. And so how's this work? So I have my gaming rig with version 0 of my code that contains an infinite loop. I have my gaming rig that has a version 1 of my code that contains an infinite loop. And then I'm in class and I start writing, oh, and I have some new version that is going to live on GitHub, right? So I've checked in some code onto GitHub. But I didn't sanitize my inputs. What's that mean? Well, so maybe I have something where I'm turning numbers into, or strings into integers, right? But if you don't sanitize your inputs, you might put something in there that you can't actually change, right? So you can get value errors. So I'm still getting value errors in my infinite loop. And this is pretty easy to express. We can say, what I do, while one, print int input. Right, okay, and that only happens once, or I can do, is this right? Does anyone know what I'm doing? Oh, that's cool. Oh no, what's gonna happen? Who knows what's gonna happen? You all know what's gonna happen. Say it's the answer is on the screen.
Value error.
Thank you. Okay. So I fixed that somehow. And I probably do that with like a try except or something. I don't know how to write try excepts. Okay, let's get out of here. Okay, so you sanitize your inputs in class, like I was unable to do. You grab the GitHub version of version 0, right? And then you have a laptop version. And that's the laptop you're working on in class right now. You notice it has the bug, so you fix the bug. And so that's a new laptop version. And then you save that back to GitHub and then head home to play NetHack on your $12,000 US gaming PC. Is that a real thing that happens? Do you all know what NetHack is? Goodness sakes. Okay. So NetHack is, what is NetHack? It is a video game. Is the most elaborate role-playing environment you are ever likely to explore. That's not very specific. It's an open-source single-player roguelike video game first released in 1987 and maintained by the NetHack dev team. It is a fork of the 1984 game Hack. Okay, it's browser-based D&D. Okay, check it out. The only person I know that has a job as a game developer played NetHack and told me if I was really hardcore, I'd play NetHack. So I installed it and played it for like a few hours, and I was like, geez, this is awful. And went back to watching Subway Surfer TikToks, which is what I do for fun at home. All right, you realize you also added some ASCII art and try to send that to GitHub. Who loves ASCII art? We all do. That's right. Yes, thank you. Yeah, I saw that. A+. Just kidding, there's no A+. You can get an A if you want. And in fact, you voted to give yourself one, so you can do whatever you want now. Okay, do you all feel more like free than you did before? Is there like a weight off your shoulders? There's also a weight off my shoulders. Okay. Blah, 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 ASCII art, slam it into GitHub. Wait a minute. There's a GitHub version 1 that has some nonsense in it. And that nonsense is ASCII art plus infinite loop fix plus input sanitizing. And then there's also the gaming rig version 2, which doesn't have the ASCII art, which means that when you try and check both of these things into GitHub, the repository explodes, right? Look, it's a little firework emoji. Ooh-woo. Okay, and so we can have versions of code that live in more than one place. Wait a minute, versions? Versions? Someone say something about versions? Maybe the final in this class was to make a version control system? Oh, so you have to use version control to learn version control? That's recursion. Okay, so anyways, that's what we're doing today, or this week. You're going to create repositories, and you're going to create tokens in browser GitHub. You're going to use the command line to configure a repository. You're going to authenticate via access tokens, or SSH. You're going to use git add, git commit, and git push. Do you know these things? Have you used these things? Okay, very good. You're going to use git pull to grab saved work. And then you're also going to use a git ignore file. Let's zoom out a little more so we can see all of our lines of code. No, we can't. Okay, whatever. Course sketch. Okay. This is how I have laid out our course this term. We can debate the merits of this, and I'm kind of curious your thoughts. The problem is it's at the beginning of the semester, so you forget by the end, so I don't see anything in course evals. I've been structuring all of my systems programming classes. The first thing you do is you redo one of the CS1 assignments in a real programming language. The problem with doing something non-trivial in Python is like Python kind of does it for you, right? So like when you're writing Wordle in Python, Python strings are also a collection type, so there's like all this stuff that just happens automatically, right? And that's really cool for teaching you how to get started, and not really cool for teaching you how computers work, right? So there's pros and cons to this. So I really like to revisit this. Last semester we did Enigma. This semester we'll do Wordle. Wordle is very similar to the recommended starting assignment for Rust, which is a guessing game. So that's very exciting. So once you do Wordle, we're going to say you basically know Rust, and then I'm going to start teaching you stuff and expecting you to do it in Rust, right? Why are you laughing at this? This makes perfect sense. How many of you have learned a programming language like after already knowing a programming language? Was it easier the second time? Is there any difference between programming languages at all? No. They're all Turing complete. Okay. We've got two exciting things going on here. We have an algorithm, the least common subsequence algorithm, and we've got the version control system. These three things here are cryptographic technologies, SHA 512, which is going to teach you to write code that you think is complicated, but it's not. It just like seems complicated. I don't know, it seems complicated to people. There's ED 225519, which was specifically requested by Sam Holmes, who then did not enroll in this course. There's the Merkle tree, which is my favorite data structure, so I get to teach it because I'm in charge of the class, and it happens to be used in version control systems and also in Bitcoin. So all of my systems courses go through a Merkle tree. And Merkle trees use hashing from SHA 512 secure hash algorithm. So this is a way of ensuring that there is a series of information that has not been tampered with. This is useful in blockchain, and this is useful in a version control system. I'm also going to teach you a little bit of theory involving graphs. So some of you have done Wordle before, and you probably noticed that the set of valid 5-letter words in the English language can be represented in a graph structure, where edges are letters and leaf nodes are valid words, and absent leaf nodes are invalid words. Does this make sense when I say that out loud? Okay, thank you. So we'll play around with the graphs a little bit, and that's going to basically set us up to implement least common subsequence. So I think once you've done all of these things, it's unreasonable to conclude you don't know pointers and recursion and a systems programming language. And I think once you've done all of these things, you can implement an operating system. Though someone will have to teach you how to implement the operating system, but they won't have to teach you how to write code, right? So that's the goal of this class. I hope this makes sense to you, and I hope it makes sense to me. SHA, secure hash algorithm. Okay, so SHA is kind of a big deal, and let me motivate it with one example. So I think we probably all have the same favorite operating system, which is Ubuntu, right? That is the most silent you have ever been. And I think if I press download, oh, that's going to take me straight to, like that's going directly to a download link right at the bottom. It looks like it's thanking me. Let's see, how to install, download an ISO image. Wait, why am I using the long-term stable version? I don't want stability. Please don't start downloading. Oh, okay, sign up for the newsletter. I think we're safe. No! Ah! This is not how I'm accustomed to installing my operating systems. Ubuntu, SHA key. Here we go. How to verify your Ubuntu download. Okay. Verify the SHA-256 checksum. Okay, so what's supposed to happen when you download Ubuntu for the first time is you're supposed to compute an SHA sum of the thing you downloaded and compare it to the SHA sum that they give me somewhere on this page, presumably. But I'm not seeing it. Retrieve the correct signature key. Okay, here it is. They're here somewhere, probably. Does this make sense? There's a number that represents what happens if you take Ubuntu and you slice and dice it up, and you add all of the slices and dices together, and you get some big, happy 256-bit number at the end of this process, right? And a 256-bit number is a number that is represented by bits, which are either 0 or 1. So that is a number between 0 and 2 to the 256, which is approximately some large number. Let's see, so 2 to the 10th is about 1,000, so that's 1,000 to the 25th, so that's a 1 followed by 75 zeros, right? So about that big of a number. So not an enormous number, right? It's a number that fits in a tweet, okay? Or, sorry, we call them bleats now because we're all on Blue Sky. They actually call them something else on Blue Sky, but I can't say it in class. Okay, and so that is the usefulness of SHA 256, or 512. When you download an executable program off the internet, you want to verify it wasn't tampered with. It is really difficult to move large amounts of information over the internet without tampering, but it is very easy to move small amounts of information over the internet without tampering, right? So you take a small value and a large value, someone computes a function over the large value, and it gives you the small value. And for an example of this, we can generate a number that has about, 75 digits in it. So how would we do that? Is that going to work? Does that look like about 75? That's close enough. And we can compute the hash of that value, and we can get a smaller value back. So that's essentially what we're doing here, right? So that's SHA, and it's a way to trust things that you download on the internet. Now, they can't put it on the internet if it's not true, but they can have typos, right? Typos are not banned on the internet. So this is going to teach you to reason about bits and bytes. The way SHA 256 and 512 works is they are recursive algorithms that involve moving bits around in memory. That's what I'm teaching you this term. It's very useful. Now, it is extremely against the rules for me to teach you to implement your own cryptographic hashing algorithms because you're supposed to use ones that people that actually know how to write code work that don't have bugs in them, right? So I'm going to teach you to make something you're never allowed to use and I wasn't supposed to teach you, okay? So don't use any code you write in this class ever for any reason, right? We're just here having a good time, right? Here for a bad time, not a short time. That's what I like to say. Okay. ED 255.19, I think is how it's pronounced. One of my all-time favorite algorithms is RSA, which is a public key algorithm. And it's now insecure, so we're not supposed to use it anymore, which is sad. It made me sad. I got all up in my feels about it. I have to check what time it is because I have no idea what time it is. What time does this class get out? Is it in
33 minutes.
34? 34 minutes? Okay. That's not a multiple of anything useful. It's like 2 times 17.
Makes you feel better. It's 33 actually.
So it's actually
See, there we go.
divisible by 11.
Yeah, the prime factorization is much nicer there. Okay. So public key signature system, the way this works is I have a secret that I'm trying to convey to a specific other individual. By individual, I don't necessarily mean person, I mean computer, so another entity. I need to convey it across the open internet. I need it to be a secret, and we cannot collude in advance to come to some widely agreed upon way to sort of pass these things through the Enigma machine or whatever we want to do, right? So the person who I'm trying to get my secret to creates a number. I basically multiply my secret by that number. It's really hard to factor out their number. And then I send the multiplied thing. It's actually exponentiated. I send the exponentiated thing across the wire. Looks like gibberish to everyone because in fact it is. The person on the other end knows a secret number related to the first number and can perform a division and get the original content back. This is really useful if you want to transmit your credit card over the internet, right? Which I do all the time because I have to buy not dolls, they're action figures, right? Like a Space Marine, there's not dolls of Space Marines, right? Those are miniatures, so they're cool. And you can have them without having a gender identity crisis, right? Okay, so that is what ED 255.19 does. ED 255.19 uses SHA 512, so it has a dependency back to the earlier assignment. So this is very useful. This is one of the reasons we're going to use SHA 512 instead of, when I was showing you on Ubuntu, they were using 256 for everything. Sometimes you need more bits, right? So we're going to do 512 this year. This is going to help you reason about using computers to do numerical operations, which is not as easy as Python would have you believe. We're going to introduce graphs. This is about organizing files. So the file system is a graph. It is a tree. We're going to use it to compare files. Edits to a file can be understood as a tree. and we're going to use it to track changes. So that is the basis of our version control system. We're going to stop thinking of text files as being perhaps an array of characters and start thinking of them as being a tree of edits. Okay? The longest common subsequence is a famous algorithm. You find the longest sequence of characters in the same relative order in 2 or more sequences, but not necessarily contiguously. It is often solved using this technique of dynamic programming, where you compute partial solutions, save the solutions, and then backtrack to them if a candidate solution becomes invalidated at a later stage. Dynamic programming is very exciting. I don't know for sure that it's taught in algorithms here. Even if it is, you should see it again. We're going to use it for file comparison. Have any of you heard of diff before? This one? Okay, so I can, for example, create a file. What should I do? We'll make a Python file that does something. We'll do factorization, or no, factorial. And the way this works is if x is 1, you return x. Does anyone know how factorial works? And if x is greater than 1, you return x times fact x minus 1. Is that factorial?
Yeah.
Okay. I'm trusting you all. Okay, we're going to save this. What did I just press? Wish I knew how computers worked. Wow, how many times did I do that? That's crazy. Okay. Ah, I deleted a line. Okay. It was return x times fact x minus 1, right? And then we're going to save that as fact.py. Okay? Okay, so that's there. And then I'm going to make a new version of this. We'll just open up fact.py again. And I think I want to put this in one line because that's the type of person I am. So we're going to return x if x equals 1, else x times fact x minus 1. I mean, if we're going to do that, it might as well be a lambda expression, right? So lambda of x is that. We're just going to call this fact equals lambda of x. I'm going to delete the rest of the file. Okay, and I think I can save that as fact. I should increment this somehow. We'll call it fact. That makes sense, right? So I changed the A to a B. So this is obviously the next version of the file, right? That was obvious. Okay. We'll go ahead and exit. And then we can diff fact and fact. There's no difference? That's crazy. Wait, did I update that one? Oh, that's sad. Okay, that's no problem. We can edit one of them. I don't actually know how any of this stuff works. Okay, so we do def fact x is, I think that works. Okay, so this is a way of looking at differences between files, right? And I guess this entire file is different, which is a little bit annoying. But we want to compute the longest substring, and so what I actually would have liked to have happened is if diff could have detected this similarity right here. So this is the longest common substring. Diff, the reason diff didn't find that substring is diff only looks at lines, which is a pretty interesting way to break things up. And I think for the final you will be encouraged but not required, because you can do whatever you want to look at things line-based, because that's an interesting way to look at code. Lines of code matter a lot. But this is an example of a long subsequence. So there you have it. Does it make sense that there are both similarities and differences between these files and they could be tracked? That's the takeaway here? Okay, good job. Thank you. Okay. Merkle trees. Do you all know what a binary tree is? Do you all know what a tree is? No, like a real tree, not like a biological one.
Oh.
It's not real unless it's a graph, right? Okay. So I take a tree, And a tree is a graph where nodes have at most one incoming edge. It's a directed graph where nodes have at most one incoming edge. Does that sound right? Yes? I'm seeing some vague nodding. Do you all know what graphs are? I will teach you what Merkle trees are later in this term. Is that good? Okay, all right. An example of a tree is the file system. It is difficult to embed one of these in a linear data structure, such as an array or list. This is an R library I wrote for some reason. Oh, to get a publication so I don't get fired. That's right. Okay, so this is the root directory, which is named R. There's a file called description. There's a file called makefile. There's a file called namespace. Then there's a directory called R that contains something called vcd2df.r. There's a directory called man that contains something called vcd2df.rd. Does anyone know what RD stands for? Any data scientists? There used to always be lots of data scientists in my class, and now I don't think there are any. Did one of you scare them away?
You've converted them all to computer science.
I converted them all to computer science. Amen. On God for real. Get hype. Okay. The thing that I always get in trouble for saying is, oh, data science and computer science, that's the same thing. Everyone hates that. Okay. So anyways, this is an example of a tree. Obviously, you can express this in a linear data structure if you want to, but how would you do that, right? Shovik left when I made fun of data scientists. Everyone remember that next time you see Shovik. Okay. Your final is to implement a minimal Git in Rust. It must be self-hosted. What does self-hosted mean? So Git, the version control software of the same name. Git version controls itself. So the way to measure the maturity of a version control software is if it can be used to track changes to the version control software itself. This is what self-hosted means. Self-hosting is a kind of cool high-level concept in like showing off in computer science, where your open source software is considered mature, ready for, I don't know, doing whatever it is the code does once it's self-hosted. For an example of this, Rust became mature when there was a Rust compiler, so something that could take Rust I write and then turn it into machine code. It was itself written in Rust. This is generally considered cool. Python actually is sort of like fighting tooth and nail to get this distinction with the PyPy version of Python. So I think MyPython is written in C because it's compiled with the GNU C compiler. But there's also, does anyone use PyPy? Does that sound right? Snap install? I'm gonna try apt instead. My password is, of course, password. Unable to, okay, fine. Sudo snap install. Okay. Typing is hard. Oh, we should do monkey type. Is this what I'm trying to do? Wait, how long is this going to take?
Well, so Snap is
counting
bundling all their packages together generally. They don't have dependencies like the normal Linux packages.
Oh, so it's basically installing a VM.
Lighter than a VM, but yeah, kind of containerized.
I'm getting sleepy. Wait, this is also compiled with GCC? On Red Hat? I got Python 2? This is Python 2.7. Watch this. Okay. Print is a keyword instead of a function in this version of Python. That's disgusting. Okay. Anyways, this is PyPy. It was supposed to be Python written in Python, but it says GCC here, so I don't actually know what's going on. Okay. Vim. You're required by law to have an opinion on Vim at the end of this term. You're not really required to use it. The reason you're not required to use it is there's no practical way for me to require you to use it. I would require it if I could. The reason I would require it if I could is sort of like the same reason your body requires you to sleep more than 75 minutes a night over the average of 3 months, which is that if you sleep more than that, you can think faster and you can do things with your brain you couldn't do otherwise. Vim is the same way. Specifically in this class, when we are dealing with subsequences of strings in a file, it is especially useful to use Vim because Vim is a tree-based text editor in a way that it will sort of become obvious to you over time as you use it and as you think about version control systems. So I tried to require Vim last semester, and I found out that Microsoft really hates Vim and has $1 trillion. And they got to you before I did. So I'm not requiring it, but I wanted to rant about it for a minute. So I've done that. Okay, what's Vim? Vim is a console-based text editor. You can use Vim, you can use NeoVim, you can use Helix. Do we have any Helix users in here?
Starting the transition.
Would you recommend it?
I've not. I'm still very Vim build, so I'm still
Okay.
getting used to Helix.
Yeah, so Helix is the reason to have Helix softly recommended in this class is Vim is written in C, Helix is written in Rust. It's a Rust class. You might want to make changes to Helix, right? Someone's going to write Vim in Rust, and probably has. Who cares? But Vim is the text editor I showed you that I was working with, right? It is the mark of the maturity of someone who is comfortable with computer systems to be comfortable with Vim. It is not a mark of maturity to prefer Vim. You can prefer whatever you want, but I would like you to be able to use Vim. That's all. How many minutes do we have left? Okay, I'm going to try and learn your names while you all install Windows Subsystem for Linux if you're on... okay, no, there's an easier way to do this. Start the lab. It's called Rust Up. It's just the next slide. Wow, that is really zoomed out. How do you... Okay. Get started on that. I'm going to walk around. I think some large number of you, I'm supposed to know your names already because I've had you in classes before. So if I ask you your name, I'm portraying a character that forgot your names, okay? I certainly know all of your names, okay? But be kind to the character that I am portraying, okay? I'm going to ask you for spellings as well. Some of you are familiar with the spelling technique I use to remember names. So, all right, I'm going to walk around, get cracking on this.
So
Ryland? Okay, R-Y-L-A-N-D? Okay, so I do remember it. I just good to see you, Ryland. How you doing? Good. All right. I definitely know your name. What is a long summer? What's the first letter of your name? Is the second letter A?
No.
Is it a vowel? Which vowel is it? Does it end in Y? Is it like an M in there? Oh my gosh. Wait, am I confusing your first and last name? Okay, let's get spelled together.
a little bit.
Wow.
How did
I'm sorry. Can you remind me of that? There was a Y at the end. I thought you said there wasn't a Y. Okay. No. Okay. Right. Yeah. Okay, I remember your last name. If your last name has 7 letters. Welcome back. Goodness sakes. Oh, I knew the double letter. I didn't know what the double letter was. That's weird. Okay, cool. You have a double letter. So you have 2 double letters? Right. Wait, I didn't spell yours. T-I-P-P-Y. Cool. All right.
D.
Shit, I'm getting Linux 2.5.10.
X.
Wait, who are you spelling?
What do you have? E-L-L-I-O-T-T. Yeah.
I have 33%. It's 40%.
What up? Is the second letter here?
Oh, it's slowing down.
Third and fourth letter is the same sound.
Don't crash.
One could argue.
Old memory. Bullshit.
E-C-K.
Oh, is this a perfect?
Are you in math?
That's your problem.
Oh, never mind. 80%. Yeah.
Why are you?
You're a math major. Oh, I was gonna do CS, but then I couldn't take algorithms. So.
No math.
And also because I think
if you want.
what?
You can try and cook something if you're into it.
I don't think what's the analogy that's happening right now.
I can administer probably an atomic theory and studying because it counts.
Yeah, it's just because they like change the dependence.
We do change everything.
And also this, like all the computers, like I want to do CS because I want to learn how computer works, but all the programming, IT work or whatever.
There's software. And in fact, it's software.
That really feels like something
It's disgusting.
No idea what
you
you
might want to look
All university around.
That's not what I
Oh yeah, why are you following my friends on Letterboxd?
Wait,
Oh,
really?
I'm trying to get ideas for a big smudge.
Which friends?
You all have atrocious taste.
Oh, you're not following myself too. Okay.
Yeah.
If you follow me, I'll follow back. And then you can unfollow me.
Bonnie.
Follow
what's his
me.
last name?
I don't know. What's your name?
This is Eric.
Eric.
Yes.
What's the last name?
R-I-C-E-R-I. Okay.
Okay. Yes.
Okay.
What is not so? What?
Nice to meet you.
I don't think I have any idea what your names are. No, no. Give you the backs.
Also, yeah.
Maybe 6. Eric, okay.
Yeah. And I said that
Because I like to spell it.
big here would be great.
Yeah. Drink. Yeah. You're in with a C? Yeah. 5 letters? Gary, C, D, D. I'm going to start over.
Heard from my back.
G, E, R, E.
Let's see.
I just got mine. What was your language? Softball. I'm tagging right now. A minute. Oh, are you 4 letters? The middle 2 are vowels. Liam. Nice. Super slick. Wow. Like I feel really bad.
That looks sick.
I'm kind of feel bad. Do you want to know you? I don't.
It's awful.
Okay, cool.
When you be found, you
No.
it's what
No.
it
What should I?
is. Required features not so.
I'm gonna try and spell it. People slow down. It also
What if I did it?
Yes.
Yeah.
Mouse is my class. I didn't do anything.
We know.
No, you want yeah.
That's true for most people. Yeah. Cool. What's your name?
Right.
What? What year are you? You're a junior, and I advise you.
Actually,
the first time.
PowerShell.
Because I'm trying
Oh, cool.
Was it download
Okay.
The program's being
It doesn't like include like mouse away from
a lot of which are class.
Awesome, great. I tried to add a class. I was reading my schedule. Gateway to add a class. Right.
That makes sense to you at a high
And
level.
turn 11:30 through 12. I think that's more on classes today. I probably sit down.
Yeah, just like marinate.
Oh,
Like,
yeah.
so it's like 1 minute late.
I was thinking I had to wait.
Yeah, so the year you joined this,
So it makes you
Yeah.
it was only a BSCS.
Yeah. Wait,
That
how is
BSCS
it?
had 10.
Oh, is it for?
I hope I haven't installed this thing
for
3
music,
times.
like real music? Okay.
Yeah.
So now we've taken that class, and that's the BA.
Oh yeah.
Now, for your year, but you've now added just BS.
Yeah, you have the same one I do.
Biology.
Real psychology. Yeah. It's
16
awesome.
classes is also
It's like
coincidentally the same number as the
real
previous
life.
one.
Yeah.
So it's almost like one. No graduate tuition. So
What are you running?
Because that's engineering style BS.
Oh, so you just felt
And
you just
professional
Yeah, I did.
finance.
Yeah.
Probably
I did it like 20 minutes ago.
There's no errors?
That's sort of how it's working out.
Or if there were, I didn't read
You have every right.
So it says it's user error. Type WSL install
Oh, yeah.
distro. So you have to
Yeah,
have
that's
to
it.
install
That's
that.
it. It's like a rim.
I don't think it was like our last history. Yeah, it's last year.
Yeah, like
I thought it was in the room when I went in the search now.
Sure.
We switched labs.
Oh, yep, it works.
Is it because like China's
Oh, it crashed.
That helps so much.
Let's try it again. WSL, let's try it again. Oh, it crashed. It doesn't matter, man. No, you have to go on here.
I thought it was like
Look up the SL West Online and just install.
You're gonna join it.
I would guess Kate and I was like, you're asking what is
Let's find out when Calvin comes over.
So I did the
now I
specs.
don't remember your brother.
I did
Oh no.
Okay,
You
it's
just need to click WSL install,
Oh, I told you.
and then you put the name in there. You put
I was arguing both sides,
There you go.
but I
I did
will be
it.
okay. She's back to
I don't think we're listening to the
punctuation.
You're right. I don't know if you're right. I don't know this.
Okay, well, there we go.
Download.
Good to see you again.
I can't reach.
So that one is an awful. So you managed a long time.
27% of my meeting. Erase it.
I think I'm actually dyslexic for. Yeah. Because I have tried, and like I can totally learn just from here. Or like through the notes that rolled up my
See WSL manual
Oh, true.
installation.
You can't read it right now.
Like you would just like.
So then, no, I want to know.
God must be through his ears. I want you to go.
I think
You think so? Can you say that louder?
I'm not gonna think about this too much.
By that I mean, you know.
Also, wait, sorry. Your first language is also
Instead of working with this, you work in
Yeah, there's
No, I don't know.
privacy thing.
I mean, yes, I have.
well, PDF and on the Java spelling form with like 3 words. I didn't realize they were just going to be on here.
Yes,
second. I use Python index. Letters back 1, 4, 5.
That's Susan.
Susan Eagle. My ability to think about words.
The thing is, I'm pretty confident I remember your last name.
Please do that.
But I think that's because I remember your email address.
Well, I get this.
I'm choosing kind of this.
Susan Eagle. I know what it is.
Oh,
Or, I don't know if it's Stefan or Steven. Stefan. Stefan.
With a PH.
Stefan.
Okay. Because there's Sophia too. Sophie. And that is.
Yeah, this is German.
Yeah.
What's that inclusion?
No, Chrome.
It's the freaking PH guy. Parse PH is I had a student CC and purchase had an Al which I parsed this
That was this cooked spelled with
It's like that's not like a 8 letters.
Yep.
Ooh, I don't know the inflection. You have an E in the something position. I don't remember the inflection on that. So I think your name is.
This is great.
I'm gonna try and say it. I don't know if I'm saying it right. Cordelia. Cordelia. Okay.
I get lots of different stuff.
Okay. Yeah, you have a Y.
Maybe.
Evan, but it's
Yeah.
like E-V-Y-N, right?
Yes.
Oh, I didn't spell it. C-O-R-D-E-L-I-A. So,
Another question. This.
yeah.
Why no work?
What'd you try to do?
All I did was install and had to get that error. Well,
I would Google it.
Google it. Yippee! I love
It
Google.
could be something with the service.
Let's look it up on good old.
You want to do some good old Sunday crash.
There isn't one that's access to the password. Yeah.
That's just
Find it. The error is failing
that's
to
not
virtual machine. Keep access Hyper-V host.
Oh, I remember. I meant that.
Okay, that works.
No.
Do this one.
My name's Calvin. Nice to meet you.
Jeff.
Your quantum
I actually, I
starts
didn't have an
and
error. I was trying to, find my windows. Yeah.
started at Tuesday. I thought your next class was right after this one.
So that ends at 6. Yeah, let me go to 4. Okay, that's next. Yeah.
Yours is the Monday one?
I haven't tried it.
Monday, Monday, Friday. Monday, Friday. It's fun because it's Monday, Wednesday,
Oh, wait, yes.
It'll be fun. Okay.
It's much more just click send.
Just put it, yeah.
Hey. Should I take this class or should I switch to computer vision? How similar is this going to be to crypto?
Oh, there we go. And now I reboot my computer.
Okay, I'm going to go to computer vision after this.
Special friend called ChatGPT would do. Yeah.
Okay.
You mean I send it to my
Sure. Okay.
new chat.
Do you have
C O R Z.
A little bit. I've used it before. Okay.
There's
a
no
lot of people, I guess, we like different perspectives.
true acts. That is some crazy other chat.
This is I haven't that many other cryptos. Okay, because it said it wanted, which was my good if you're over your data for somebody who's important. So I was concerned about that, but
Yeah, you can try it out. I think it's like
Landing in a place.
really, okay. Okay. I will do that.
What now?
Was it oh, G-Chat? What does that mean?
It was spam.
Hell yeah.
My birth name is No.
You can also like spell
I've found
Like,
both.
you think I got
Yeah,
You're quiet right afterwards. I'm so ready for that. What do you mean customizing features? What do you mean customizing? Oh, and it's already done.
So it'll always be, if I'm back now, just that's the need.
And then you said, I hope you should work on much right now.
My album feature is already done. So
I remember your last name.
you told me. Okay.
Okay. I'm just so pissed about it. I don't remember what it is. I just didn't realize that.
really good work. Surely.
Yes, I'm sure. I have one class.
You get it ready.
And either I or you will text it in a group chat between the conversation. If I figure that or so it's not maybe. We'll find out if it's 66%, 70%, 75%. Promising. What do you think?
Yeah.
Did you close that?
Okay, I'll try that.
Then just sound like half my screen go white. Yoga.
Students, class is over. See you Wednesday. Getting Rust working. It was nice to meet all of you, especially those of you who are already using
Another hour and a half section here. I know. So let's see what works. Like 7%. I'm gonna go back upstairs and make it. 90%. It works. Yes.
I did I'm a very good data scientist in the computer science. Not computer science in the data science.
I didn't realize it was so
Yeah.
No, send me an email. But probably like, do you want to do like after class?
Yeah.
We'll do that revision. Like, send me an email.
Thank you. It still isn't working.
We'll figure it out next time.
Okay.
Thank you.